Good evening. I hope you all are doing well, preparing the best for your board examination. But I have selected this topic to discuss with you today so that you are not confused in selecting sums from differential equation, what to practice actually. Just before starting the session, I would like to tell you that most of you are commerce and are students. Biology is not in your syllabus, nor physics also. So any problem where concept of physics and biology involved, solution of it not expected from you. And I tell you that your differential equation syllabus is huge. You must have seen past year's question paper. They are asking questions on formation of differential equation. This is maybe solution of differential equation. It may be on application of differential equation. But those who are qualified on this topic, they normally don't want to miss even 1 mark from there. This session is meant for them. Those who are thinking what exactly are to practice before the board examination. Because differential equation, it plays crucial role in modeling real world phenomena. They are used extensively in biology, economics, business to describe growth, decay and various other dynamic processes. And here I am going to cover essential concepts and problems to enhance exam preparation for students of applied maths. Those who are pure maths students preparing for entrance examination, this application is important for them. Even application is there in their syllabus also, they can go through the system. So I will be just taking 1 or 2 minutes time to explain what is expected from you in board examination. See the content here, recognizing a differential equation, this is what we have done, order, degree, example, formulating and solving differential equation. This part is also done, solution of simple differential equation. I did not have scope to discuss all difficult sums, but I told you how to prepare on those topics. But this one left, application of differential equations, growth and decay model. Apply the differential equations to solve growth and decay model. Growth and decay model, in this student will be able to know this. They will be able to do sums based on this growth and decay model in biological sciences, economics and business, etc. We will start the session. Before that, I tell you how it can be used in biology. There is a problem given the answer is support material also. They are solved, I think. That is drag assimilation problem. Understanding is not very easy. Biology students even take time to understand. So assimilation of drag is not expected in your examination. I say same thing about Newton's law of cooling in physics. Not expected from you. But then why they are written biological sciences? This is due to, see, population growth is a biological process. You agree or not? The growth of bacteria in a culture is a biological process. And in economics, growth of money, that is application in economics. In business, same, economics and business we cannot distinguish. They are related and application in economics, in business, in biological sciences, even the simplest application expected from you, believe me, no need to do very difficult sums. Sums will be mostly of growth and decay model. So let me explain in brief what is growth and decay model. Just before I start, I just ask you one question because you are doing commerce, you are whether arts student or not, that doesn't matter here. Money in your group. Some are able to deposit 5,000 only. I get the amount after 10 years accordingly. You are able to deposit 5 lakhs. Then your expectation will be more. So on what factor the growth depends? Growth depends on the amount you are depositing now. There is another problem which you can take a generalized problem, that radiative decay. Don't say that it is physics problem. Radioactive substances gradually disappears. All those particles from radioactive substance gradually disappears. So radioactive decay is a process which can be explained in terms of differential equation, and here the decay rate depends on initial amount present. So in growth model, what we are going to observe? Grow money, commercial economics. Grow money depends on the amount you are depositing. Bacteria culture, number of bacteria after certain time depend on initial number present here. So decay and growth both depend on the initial number present. Without wasting time, let us start. I will just explaining the growth and decay model with you first. Okay? Exponential growth and decay. That I am going to explain first. What is exponential growth and what is exponential decay? This differential equation I am taking, dn by dt is proportional to n. What do you mean by this? This n stands for, normally it stands for number. It may be number of bacteria, maybe radioactive substance, number of molecules present initially, maybe the amount of money also. So here we frame the problem in daily life this manner. dn by dt proportional to n. But with proportionality we cannot move. We have to convert this into an equality. How to convert? This we can write as dn by dt is equal to some constant k into n. This k may be greater than 0. K greater than 0 in which case? This is for growth model. For growth model, k greater than 0. And k less than 0 means what? This is for decay model. Examples, already I told you. Investment if you do, assuming growth is there, then k will be positive. And electric substance, some substance which can evaporate, perfume, scent, whatever amount you initially keep, that evaporate. That will come under decay model. So my suggestion for you, when you are going to do for growth model, you start with plus n, and for decay model, you take this one as minus kn. Okay, keep it going. So let me formulate a growth problem first. I mean, algebraic form, not in differential form. Sometimes problem solving will be easier for you if there is a algebraic form. So let me start with this growth model first. So in 1, dn by n will be k into dt. Am I correct? This will integrate both sides. integrating both sides, what do you get? dn by n k into dt. Alright? What is dn by n? This integration all of you know. Log n equal to k into t plus a constant c. No base is there, exponential base we have taken, it means, isn't it? So n will be e to the power kt plus c. So it will be e to the power c, e to the power kt. E to the power c stands for what? This is another constant, we take it as big C, capital C. So capital N will be capital C e to the power kt. This is for growth model. Okay? Now this value of C we can state. Initially means when? Initially when t equal to 0, n equal to n0 say, initial number. Then by using this we get n0 equal to c e to the power 0. C is n0 only. Clear? So therefore, n will be equal to n0 e to the power kt. This is true for growth model. And graphically, if you face any problem in board paper, they are asking on graph, whether it is growth model or on decay model, you can write, you can draw the graph this manner. Or this graph ensures there is exponential growth. This is for n equal to n0 e to the power kt. This is growth model. Okay, graph for that. This is graph of the growth model. Okay, and this is the equation available for growth model. Since in support material this is derived, you have every right to use it if you are efficient in doing so. In exam you will definitely use it. In MCQ you will do. Descriptive also, we started the problem with this assumption. We know that growth model is this, n equal to n0 e to the power kt. Clear? Let us see for decay model. What happens there? dn by dt equal to minus kn. Let me derive it in details for you, so that you remember better. For decay model, what will happen? Let me do. For decay model, dn by dt, relative disintegration, evaporation of perfume comes under this category. So dn by dt will be minus lambda into n. Therefore, dn by n will be minus lambda dt. Okay? So this implies dn by n minus lambda integration dt. We are integrating both sides. So what will happen there? dn by n, same value over there. dn by n, this comes under logarithmic integration. Log n equal to minus lambda into t plus c. No base is there, exponential base, e to the power minus lambda t plus c. So e to the power c, e to the power minus lambda t. Therefore, this again will take big C. What's the difference with the previous one? Because minus lambda is there. It's decay, it will gradually reduce. That's why. And this big C equal to e to the power C. So C e to the power minus lambda t. Clear? So this is for decay model. Again, C we can write in terms of initial number. When t equal to 0, let n equal to n0. So n0 will be c into e to the power minus 0, c equal to n0. Clear? So the equation changes to this form, n equal to n0 e to the power minus lambda t. Alright? This is relative decay or any decay problem. Exponential decay is in your syllabus only. So the graph for it, if you are asked to verify, the graph for it will be like this. It is decaying. No, don't take so much. You just start from here. From some initial number, it is reducing. This time it is reducing from n0 dash v. Okay? This is t and this is n. When the substance becomes half of the initial value, then the time required for called half-life. When it becomes n0 by 2. Sometimes you need to calculate a half-life. So what is half-life? Let me explain in decay problem. Half-life. Now when t equal to t half, n equal to n0 by 2. Therefore, n0 lambda into t half. So this implies, understood, e to the power minus lambda into t half. Okay? So taking log of two sides, log half minus lambda t half. So minus log 2 is minus lambda into t half. T half is what? Log 2 by lambda. This lambda is what? I remind you, decay constant. Decay constant has another meaning. What is that? Decay constant can be termed as rate of disintegration or rate of decay. Rate of decay of a substance. Okay? That is rate of disintegration. So log t half you can find easily by using this formula log 2 by lambda. Clear? Let me find very simple application as suggested by the NCERT support material. I hope all of you are carrying this NCERT support material. I have selected a few sums from there to discuss with you in this session. You just go through those sums. The first one you see, first problem you go through. Yeah. These are the problems I am going to discuss with you today. I have selected sums from most authentic study material for you, those who are applied math students. That is given by support material that was made by NCERT CBSE. Okay? So let us work on it first. We'll be solving these sums here. Find an exponential growth model y equal to y0 e to the power kt that satisfies the stated conditions. What's the condition? This is the condition y0 1 and doubling time t equal to 5 years. What I told you, you can use this. I did not change the sign. What inside the support material is there, I have kept the same symbol. First tell me, this comes under category of growth or decay. Obviously growth, because it is stated over there, this should be growth model, isn't it? This is under growth model only. Growth model, this equation we got it in this form. N equal to N0 e to the power lambda into t or k into t, whatever you see. K or lambda, sometimes I mix up. K given here. Y0 equal to 1. So put 1 over there. Okay, we'll put later. Given y0 equal to 1. And it doubles, 20 equal to 5. When t equal to 5 years, y will be twice y0. So 2y0 equal to y0 e to the power 5. These two are getting cancelled. Take log of two sides. Taking log of both sides, it will be 5k. So what is the value of k over there? The decay constant, the rate of decay. In case of growth, the rate of growth. What's the value? 1 by 5 log 2 base e. You can go through the book. What is the value of log 2 base e? I am checking here. This is given to me 0.693147 by 5. This is approximately what? This is going to be 0.138629. So they have asked to find exponential growth model. What is the growth model here? So y equal to y0. Y0 means 1 they have given. 1 e to the power k. K we got. This is the required thing. Clear? Hope you have understood. So required growth model is y equal to e to the power, it goes on increasing. Graph I already shown you. Whenever growth is there, exponential growth is there, graph will be like this. Goes on increasing. Okay? And this is t. Alright? Go through the next problem. This is also a growth problem. In a certain culture of bacteria, number of bacteria increased 5 times in 10 hours. How long did it take for the number of bacteria to double? This kind of simple problems, if we ask in board paper, will be there. Applied maths, true for pure maths also. Believe me. So first try, then I will proceed very slowly. Number of bacteria increased 5 times in 10 hours. Say again growth model. N0 e to the power lambda t. See, I am not taking the risk of writing differential equation. If I write, then also I can solve. dn by dt equal to lambda into n or k into n. Its solution is this only. We have proved. N0 stands for here what? Initial number present. The number of bacteria increased 5 times. So, when N equal to 5 N0, T is going to be 10 hours. Therefore, this value also you substitute, that is 10. This two getting cancelled. Again take log 5 base E equal to 10 lambda. So lambda equal to 1 by 10 log 5 base E. If you know the value 5 base E, actually in board exam it will be given to you, don't worry. You will get there. Okay? In exam, it will be given. Over the data will be given over there. It will be asking that also. Okay? So let us write the value of log 5. So log 5 will do later. Wait. Now let's see how long will it take for the number of bacteria to double. This was number 1. This is number 2. When t equal to t dash, let n equal to 2n0. We'll be using same equation. So 2n0 equal to n0 is the power lambda into t dash. These two get cancelled, isn't it? Again take log. Lambda into t dash equal to log 2 base E. Alright? Log 2 base E. Now go on dividing. Just dividing. C by 2 by lambda equal to log 2 base E 1 by 10 log 5 base. So this is 10 into log 5 base E. Recently we found the value of log 2 and log 5 from table. They will give you also in exam, don't worry. Okay? So from here, T dash can be found out. T dash will be 10 into log 2 base C. 0. I found it. C147 in the previous sum and this sum log 5 base C. You can go through the table where exponential base is given. 5 base E is coming 1.609438. So 6.93147. That divided by this thing. Go on dividing. Value will be approximately 4.31 hours. 4.3 hours. No problem. Understood? Go for the next problem. This one. Amount of oil pumped from one of the wells decreases at, this is decay problem, decreases continuous rate. What do you mean by this? What is continuous rate? This continuous rate means that is decay constant. This rate is always decay constant. So lambda is 10 by 100. Agree or not? This lambda is 10 divided by 100. One by 10. Now, it decreases lambda bar. So, when will the well output fall to 1/4? You write amount as A, initial amount as A0, and this is e to the power minus lambda c. Hope you agree? Because it is a decaying problem. So, decay will be in accordance with this. Now, given when A equal to A0 by 4, T we don't know. Lambda is, we have to find the value of T. What is the value of T? This we have to find. When A equal to A0, put it there. A0 e to the power, just this is A0 only, no? A is A0 by 4. So put A0 over there e to the power minus lambda t. Clear? A0 gets cancelled. Take log of two sides. Log 1 by 4 minus lambda t. So t will be what? Log 1 minus log 4. Log 1 is 0 for any base. So this is going to be minus log 4 by minus lambda. Clear? What is the value of lambda? We got 1 by 10. So it will be 10 log 4. Now substitute the value of log 4 to get the desired answer. Log 4 go to the table again. Base E, nothing is mentioned, means base is E. Its value showing, yeah, its value is showing here 1.86 years. Understood? Go for next one. This is application in commerce and economics. Gold deposited in an account paying 3% compound interest. This is the topic which you have done in class 11, compound interest. But this time we are following easier method. Just by using table, we can get it very fast. And if we can write this one as a growth problem. It's a growth problem. Amount, we are paying 3% interest over there. Solve the answer. We'll take A equal to, I'm not writing differential equation, not taking the trouble. If you find 2 or 3 marks question, this is enough. If you find in 5 marks, then you write dm by dt equal to lambda into n. By solving, we get this thing where n is the amount present at any time, n0 is the initial amount. And lambda is the rate of growth or rate of decay. Here it is. Clear? So immediately you can write the value of lambda. Lambda is what? This is growing this way. 3 by 100, 0.03, agree or not? 0.03. Clear? So, use this equation, compounded continuously for 5 years. Say, this much will be N0, rupees 5,000. E to the power lambda, that is into T. T is for what? 5 years. E to the power 0.15. Isn't it? Go to the table again, e to the power 0.15 percent value. Table is given in your book. You got that e to the power 0.15 coming to be 1.1618. Okay? Now calculate this with the calculator. I am using calculator here. Computer is available. Calculator app. So doing that. So I have to reduce the scale because I do outside calculator. You do just manually. Okay? I am doing just by mobile calculator. 5,000 1.1618. This is coming rupees 5809. Is that clear? Approximately. So this one is another growth problem. Go through this one. This is last today's class because what I tell you repeatedly, practice comes from all chapters. This chapter definitely important, but do practice what you can gaze over there. Study I told you already. Okay, let's do it. 600 grams of radioactive substance. Just read the sum. Are present initially and 3 years later only 300 grams remain. How much of the substance will be present after 6 years? Not a difficult sum at all. What is this information given? It is decay or growth, first you decide. Obviously decay, relative substance. There is no chance of growing the amount. So it will decay. You know that it decays. So engineering is how much? 1 year after 3 years. N equal to 300. So use the relation that so 300 e to the power minus lambda into C. See the problem here? There is problem. Isn't it? There is a problem. Check. So e to the power C lambda is equal to 2. Just change the side. Take it on left side, 300 on right side. Therefore, take log of two sides. Log 2 we have just found. I hope all of you remember. So taking log 3 lambda equal to log 2 base E. So many times you have used log 2 base E we know. I just check the value once again here. Log 2 base E. So log 2, lambda is vanish. Let's say log 2 base E may vanish. Okay, lambda is this. How much of the substance will be present after 6 years? Let's see what happened after 6 years. Same relation will be. Finding when t equal to 6 years. So put it there. N equal to N0. N0 is what initial? E to the power minus lambda. Lambda is what? Log 2 base E into 6. So this is going to be 600 e to the power, this gets cancelled, minus half log 2. Check one. 600 to the power minus half log 2. Isn't it? Just check one. Lambda is log 2 by 3. Log 2 by 3 put there. This into 6. Oh no, this is not half, sorry. That's right. This is 2 log 2. Therefore, in after 6 hours will be 600 e to the power minus, this you take up, log 4. 600 e to the power log 4. Just let me check the value here again. You have about 300 works here. This is 600 e to the power minus log. You write e to the power, this minus you absorb, log 1 by 4 base c. And this is a very familiar form. E to the power log x by c is x only. So 150 years. It will happen after 6 years, no, not years, sorry. 150 gram will be remaining. So how many half-lives passed here? This is a very common question. 600 to 300, 300 to 150. Half. That's why it's 6. In 3 years, it will be half. Another 3 years, it will be another half form. That's why it is 150. Hope you have understood. See you again with another interesting topic with you before the exam. These classes are not to solve very difficult sum. Very difficult sum is never be asked in board exam. Just do this kind. Practice this kind of sums from any book. But don't forget to do it from NCERT support material. Is that clear? Hope you have understood. See you again. Thank you for staying with me till the end.